Hello, welcome everyone, and thank you for joining the call today. So our community call today is going to be kicking off our first call to action, which is the experimentation phase of Hackathon. We're having our community call today on the Voice Scientific channel, so I can go ahead and experiment. But for anyone who wants to follow along, a lot of these same resources are published in the general index.
Okay, is that
So
the channel we should be following for text if we want to type something?
yep,
Or,
absolutely.
okay.
What is the channel?
The general index channel?
Yeah, I
Okay.
think that works. So if y'all can see my screen, I am sharing it right now. What you're looking at is the main landing page for a data repository called the General Index. So a team of people have collected 107 million scientific papers, have structured those papers into n-grams, which is a common data model for machine learning, search and index, and a couple other computer science functions, and have published it completely open source under the Internet Archives. So this is a public good. It's free to use. Anyone can go and play around with it. Like I said, if you go to the General Index channel, General Index Overview on our Discord, and look at the pinned posts, the very first one gives a little bit more information on what's actually there, and also gives a location for where you can go and find samples. Because realistically, this 107 million paper database is about 40 terabytes, but we do have small amounts of information that you can just come look at. So with that being said, we're kicking off the experimentation phase of a hackathon around this database. This is an incredible public good to be published online, and we want to think about the things that we can do with it. So right now, we are looking to try and find RFP around potential use cases where this could actually help foster scientific progress. Chris has a couple of those. I think Ian has worked on one as well. But just wanted to go ahead and give that introduction before I pass it off to Chris. Do you have anything else to add, Chris?
No, thanks a lot. Thanks a lot, Eric. First of all, it's great to be here. It's an absolutely fascinating data set. It is also non-consumptive, meaning that it is not in breach of copyright. That means the entirety of this information can be used for extracting patterns. We need to contextualize a little bit the types of applications that could come out of the general index. And I'm going to go over a couple of ideas, starting from more humble ones, and then building up to things that hopefully will blow your mind. So let's start with the state of scientific metadata. The state of scientific metadata is essentially pretty poor. I'm sure many of you have heard about efforts in the semantic web to create fair metadata and other essentially metadata components to essentially allow for increased machine readability. That means creating a system that is more easily to be queried, that information is more efficiently found, that is more easy to be crawled by machines, and ultimately to be used as inputs for AI models. So this is the idea behind the verification process of data. One of them that is at the forefront of the interest of funders, science funders in particular, is the idea to accelerate science as a byproduct of the verification of the scientific data. And by scientific data, I think it's very important to clarify that we don't simply mean scientific data set. So the concept of the FAIR principles applies to the entirety of data. That means manuscript is data, that means video of your work is data, all of it is data. And the idea behind the FAIR principles is to make this data machine readable, semantically consistent, and essentially to create higher interoperability and shareability of knowledge. It's a very ambitious goal. Now, the situation right now, scientific data is fragmented and often the metadata is very poor. And there's many reasons for that. One of them is that metadata is essentially something which is entered by scientists. It's a very long and arduous process to be entering manually metadata to ensure that your data is fair. You have to do things like categorize your data into ontologies, there's control types, there's community standards. It's essentially an immense burden on the shoulders of scientists, but it's incredibly important to do it. So now, let's imagine this in the context of the general index. The general index is associated with a lot of metadata as well. It's a very rich data set. What if it was possible to mine this data to essentially generate semantically consistent, machine-readable metadata around scientific discoveries? What if it was possible to improve the user experience of scientists, to reduce the cost and the burden, to essentially comply with the FAIR principles, to create a more interoperable scientific knowledge graph? What if it was simple to do? And that's something which is more or less a very ambitious application, very ambitious idea as well for the general index. You can imagine like automatically doing simple things like automatically classifying the subfields of science, right, and creating tags, auto-generating tags. You could also imagine extracting the data sets that are mentioned and connecting those with other references. There's many applications of the general index in the context of machine learning with the process of improving interoperability of scientific data and repairing our broken scientific data. That is one. There's another big opportunity with this. We want to be even more ambitious than simply working with the general index. We also want to be curating an interconnected data set that is accessible to all, that will be queryable, that not only contains the general index, but other ambitious data sets of science, such as the Open Citation Graph from the Open Citation Project, such as the PID graph. These are persistent identifiers from the Freya project, another project that was working on knowledge graphs. And all of these data sets are into the open. Now there's work behind that because we would need to reconcile these different data to connect them and that is, as many data scientists who've worked in the field know, that is, well, first of all, it's the bread and butter of data science, but it's also a lot of work. But imagine if we could create one of the biggest rich data set, which would be essentially representing the scientific record that can be used to derive things like metadata, to classify a scientific work, to improve machine readability. So that is, I think, the first extremely broad and ambitious goal that we would like to do. Now, of course, I don't want to make it feel like you need to be a data scientist in a way that is, at a very high level, at a very high professional level. I want this experiment to be as inclusive as possible. I want people to just come up with creative ideas about how this could be used in useful ways, and that's why we're going to be holding RFPs. Essentially, we'll be collecting proposals and ideas of the community on how we can use it, and in the long run, or actually probably quite soon, we'll be introducing probably things like microgrants to reward people that have particularly strong proposals in our community. Now, I want to slightly go towards a more sci-fi, futuristic part of this conversation. I'm sure many of you are familiar with GPT-3, with large language model, ultra-large language models. For those who are not, these are essentially language models that are trained on corpuses of text and are able to generate strings of text in return, essentially by predicting the next segment, the next few words, the next chapter, and using that information, the contextual information of word adjacencies to essentially create generative models. And those are becoming incredibly powerful. And I just want to draw your attention to the category under General Index. There's a chat that is called LMM, and that stands for Large Language Model. And I've posted in here an example for you that I think is worth reading, just to understand how transformative large language models will become for scientific research. So in that example, I essentially copy-pasted an abstract from one of the articles I wrote. My friend did this, actually, Arkady, my co-author. It's a neuroscience paper, essentially about a technical topic that has to do with theory of mind. And essentially, just by putting it down, this abstract in the general index section. Oh, Eric, if you're sharing a screen, that's not the right one I wanted to share. I just wanted to share the Discord channel, actually. So there's LMM as a category in the Discord channel. Sorry if you're following from that part. Let me see if I can actually share my screen. Yeah, up, go live. Yeah. Sorry, guys. Sorry. Up. I'm sharing my screen now.
Okay, I can get mine.
Wait a second.
Just a second if you want to continue going, Chris.
Yeah, I'm just going to continue going. I just want to get this working. Oh, okay. I'm just going to continue. I assume you guys are looking at general index subchannel LMM. So I just copy-pasted an abstract, and this is the type of text that's been generated in response, right? What constitutes a semi-decent introduction to a scientific paper, right? So what the model is essentially doing is, without leakage, meaning that it never saw my paper is more recent than the training data that it has used for, right? That's leakage. It is able to generate actually a semi-decent review of the literature. And that's incredible. This semi-decent review of the literature is actually accompanied by embedded citations. So I just want you to realize for a moment, of course, this is not, at a level of, at an extremely high level of expertise, but it's very good. It's better than what a graduate student is generally capable of writing when he starts his PhD study. And just contemplate for a moment the power of large generative language models in the context of scientific research. And also take at this moment to contemplate the risks associated with this. Generating such an article, is this plagiarism? What if it makes sense? What does that mean in terms of ethics? There's already farms in China, paper mills, that are essentially using GPT-3 to create these papers, right? So they're generating papers in paper mills. So now imagine the potential of having a data set like the general index that is enriched with many other data sets. What if we could create data that is made machine readable in a way that could benefit the training of such large language models, such that we could summarize the scientific literature, such that we could generate hypotheses? What if we could create a world in which scientists are actually assisted by AI to generate their work and to understand and to summarize the work? That would be an incredibly, what is called in the lingo, transformative AI, right? That would be a paradigm shift. So thank you for listening to me up to now. I wanted to give you this overview from humble, simple applications of enriching the general index, of generating scientific metadata, of classifying work, to the big grand vision that is at the horizon that will be transformative, in which we could perhaps have a small role to play, or even a bigger one. We don't know what the future holds. So thanks for listening.
Absolutely. Thank you. And that is incredible to think about. I want to quickly open this up to the audience to see if anyone has comments.
I've got what might be a brief question on other people think of stuff. So with this possible paradigm shift occurring, like what would be a super practical, tangible example of what that looks like?
So imagine doing literature reviews. What if you could automatically generate a literature review? What if the levels of accuracy of that literature review were pretty high? Like, give me weigh the evidence for and against X, for example. produce a summary of the state of the art on topic Y. There's also emergent properties in these foundation models. So they've learned mathematics, for example, which is a byproduct of learning the rules of adjacency in text. And imagine the types of byproducts that could arise from foundation models when it comes to, for example, generating meta-analysis or estimating the replicability of scientific studies. Or the robustness, or essentially a range of unknowns, right? It's very difficult to predict what will be the first use cases that will be accelerated for the scientific endeavor.
Cool, thanks.
So does anyone else have questions around this? This is, community call on the community stage, because anyone should be able to speak up and talk.
Yeah, absolutely. I'm in a coffee shop right now, so I apologize if it's a little bit difficult to hear. I had a question about whether or not you guys have given much thought to how this sort of meta-scientific AI would be governed, or if a governance aspect or element will be included for DeSci Labs.
Well, I mean, that's an incredibly difficult question. The governance of AI, how it's looking, what's happening right now in the world. And I think it's also a question that's on the horizon for governments and corporations, right? What's happening right now is that these language models, first of all, there's no way we can train ultra-large language models with the resources we have. It cost hundreds of millions of dollars to train one of those models. And that's something which means that these models will be in the hands of nation states and large corporations. And I mean, I let you think of the consequences of that. I mean, we've seen that OpenAI has essentially is very, very closely guarding some of its technologies, similar to Google and others, and especially the API to access those technologies, because of course these models are incredibly powerful and they can also be used in a harmful way. So for instance, you could ask such a model, how do I build an atomic bomb, right? You could say, how do I do gain-of-function research? You could essentially, there's very important consequences ethically that need to be thought about. And then the question is, well, if you create a permission system, you create a two-tier society. The people that have access to foundation models, let's say in 10, 15 years, and the people that don't, right? And we justify the people that don't have access to these models in various ways, right? They could be enemies of the nation state. They could be outcast. It's a very interesting question. It has a very far-ranging consequences, and I think it goes also far, far beyond meta science.
That's awesome. Thank you. I've looked into this a little bit, and it seems like AI localism is a sort of area that might provide a lens with which to view uses of AI in this way that is distributed, but at the same time in line with the locale where it is being applied. I'm wondering if you have thought about any of the sort of tracing or just AI local things for the use of science in these communities.
No, haven't heard actually of local AI of this movement. Drop a link, and I'm very curious to learn more.
Yeah, I'll do a piece on it later.
Hey, thanks for sharing about the general index. This sounds like one of the most powerful and useful data sets, and so glad to see that it exists. I'm curious what you guys think about like the potential for maybe AI to do like novel research using this general index model, like AI as researchers, in particular, maybe just in the realm of like connecting ideas that researchers might not be able to connect just because of how quickly the literature is growing. Like for example, like finding connections between I think there was something recently about like finding connections between different papers on what caused seizures, and finding that, oh, these papers that mention seizures also often mention this other condition, and that through data mining they were able to find this connection that was like highly correlated. Do you guys think something like that could also become easier and easier or more impactful with General Index and GPT-3?
So I think in general, yes. So foundation models, these ultra large language models that show the capacity to learn tasks outside of what you would assume they would be capable of doing. Those models could be generating completely new insight, right? So think of there's a very well-known features of these models. It's like you can say, explain to me X in the style of B, right? Like write down a scientific paper in the style of Shakespeare. And these are incredibly hard to do tasks for humans, right? So it's essentially these AIs are very good at style impersonation. And now think about scientific disciplines as perhaps their own styles, right? Whether their own vocabulary, their own culture, their own way of talking about things, right? Economists talk about incentive structures, about utility functions. Computer scientists, they'll talk about, process optimization, about objective functions, about these kinds of things, right? And yet these different fields do a lot of, there's overlapping work between those fields on different topics, but they don't talk very much to each other. And that's one of the reasons why interdisciplinary and cross-disciplinary work is so valuable and generates so many novel ideas. So what if you could now essentially create interdisciplinary translations, or even more than that, essentially fuse different disciplines into a common model of understanding or in a common model of communication between disciplines, right? So that would be a very creative application of the capacity for imitation that these models exhibit.
I would love to read some Shakespeare physics papers, by the way, because that sounds awesome and entertaining. And I love the idea of interdisciplinary work happening more with these as well. One thing you mentioned about the literature reviews, and that got me thinking a little bit about like peer review as well. It seems like so often one of the things we rely upon for peer review is like somebody who knows the literature well and can say, if you're talking about this field, you really need to cite so and so who wrote the seminal paper, or if you're going at it from this angle, maybe. Sorry.
Keep going. I think Chris's mic is sort of picking up some background noise every once in a while.
Yeah, excuse me for that. I'm back.
Oh, no worries. So if you're writing on some topic, you need to make sure you cite this other author on it, and I wonder how AI could perhaps serve that function of maybe doing some like very simple peer review of like very simply saying, this is the minimum literature you need to sort of have considered if you're doing research in a particular topic.
I mean, definitely. I'm not sure in the context of peer review. So the context of peer review I see as perhaps something which is a bit further after many of the low-hanging fruits have been found and revealed. And there's going to be incredible things that will happen from the revelation of the low-hanging fruits of transformative models applied in this context. For example, think about how convenient it would be. It's like, could you sum up the evidence in favor of, and then you can basically use that evidence and argument your paragraph, right? Just as an author, writing and essentially collecting information and data on things, right? The thing that we have to keep in mind is that for a very, very, very long time, there will be a relation between a scientist who acts as essentially an editor and the AI. So the real peer review that's happening here is, as a scientist, you need to peer review the output generated by the AI. And because this is where the mistakes will happen. This will essentially give you a lot of information, but we can assume that the cost of going from being very good to insanely good is actually perhaps orders of magnitudes of computation more, right? That means we have a long way to go before we can essentially generate highly accurate reviews. So we will need this relationship between scientists and machines who will be essentially, the scientists will be curating and producing prompts and curating the outputs and then incorporating those outputs in the way they're structuring their ideas. So I think that will be one of the first approaches to how these systems will be implemented in science.
Human in the loop feedback. That sounds really, really awesome. Maybe one
There's
last
a name
question.
for it. It's called centaurs, right? So that's a really interesting name. A
What is
society of centaurs, right? So centaurs are mythical beasts in Greek literature, which are half man, half beast. They're essentially half horse. So they have the back of a horse and the torso of a human. And the idea of the centaur is that the AI is the horse and the human is the curator of the prompts.
Nice. I'm ready for Cyborg Centaur Land. One last question for me is like with what you mentioned about like AI being really good at talking in the style of something like in the style of Shakespeare. I wonder what effect that would have on something like education. Like, could you maybe this is like trivial, but like AI as like teachers or tutors of like, let's say like 5th to 6th grade students, but teaching them maybe some of the most advanced like scientific stuff out there, but just being able to rephrase it in a way that makes it easier and more approachable for them.
Yeah, the vulgarization is really interesting, actually. Imagine being able... So this is an application that's used already and monetized, right? So news agencies are paying for API access to generative language models to generate news, right? So they take a prompt from Reuters and they say, generate me a news article in the style of X. Things like that. And then you have an intern who's essentially curating the prompts and copy pasting a bunch of text. And once it kind of looks good, he sends it out and then it's published, right? So the extreme low hanging fruits of generating a context and information on prompts, on news prompts in the context of news organizations are already being used, and people aren't talking about it nearly enough because and yes, so absolutely. So to go back to the point you made, the ability to vulgarize and explain scientific finding in language that is simplifying is absolutely an application of these models.
Kalki's got a question. I'll bring it in a second. In the same vein to what was just asked, though, do you think that let's say I'm like a biohacker that has no experience writing scientific papers, am I going to be able to take my experiences and my findings and maybe write it in a way that a scientist will understand?
Oh yeah, you could, well, imagine. So there's a couple of scientific styles that are very impenetrable, right, and very difficult to write. It's very hard to write a paper in economic theory, for example, or in many fields of science, actually, that have an incredibly, essentially, they use obfuscation or language or technical jargon to in a way that is necessary on one side because you want to be really, really precise with the terms you use, but it's also excluding not only understanding but participation because it requires deep study and contextual mastery to do. So yes, I mean I could see a complete revolution in the way science is both formulated and communicated as the result of these ultra large language models.
That's really interesting, that bridge between the research world and the general public. So for the recording, I'm going to restate what Kalki asked in the chat here and then get your thoughts on it. He says, I see the AI-human duo as being more like that of a photon having a magnitude of unimaginable power, the AI, but whose direction is stewarded by the human, like a vector almost. He's wondering what your thoughts are.
I love it. That's a beautiful metaphor. I mean, yes, imagine the power that is at your fingertip, right? It's the sum of all human knowledge and its contextual representation that is with an incredibly deep statistical understanding. And that power can be channeled to generate, to summarize knowledge, to put knowledge at your fingertip, and to generate new knowledge. And that's incredible. That's why it's transformative AI. And that's a term, I think, from the effective altruism community. I think you can perhaps go on Open Philanthropy. You can learn more about transformative AI. It's a really fascinating topic, and I cannot stress enough that this is going to be happening in the next 1 to 5 years.
You think it's going to be that quick? Like the this index came out last fall, and you think
No,
within
no.
Okay.
So I'm not talking about the specific index part about the general index. I'm talking about companies like OpenAI that are training the next ultra large language model is, I believe, 1 or 2 orders of magnitudes higher in terms of parameters. And we don't know what's going to happen there, right? And there's something that's called the scaling law of transformers. And essentially, when GPT-3 came out, it shocked data scientists. The reason was nobody expected, well, not nobody, OpenAI did, but most people didn't expect, most professionals didn't expect that you could scale transformer just with raw compute, right? Just feed it more data, more compute, just feed it and see what happens. And there was this kind of expectation of an asymptotic return at some point. And the thing that blew everyone's mind is that didn't manifest. You threw more compute, you threw more data, you tweaked it a bit, and you could get, an incredible performance boost. And so this is happening again. This model is being trained. It's of course not going to be available to us. It's probably going to be, closely, kept at least for a long time until they probably, do all the risk and studies. So this is going to happen, right? I'm not talking about the fact of it happening within the context of the general index and these other things, but these companies, they are building those models, those foundation models. And we don't know what's going to be happening in the next 1 to 5 years in terms of the first real powerful applications, right? So we're seeing now with DALL-E, you can actually generate incredible art using those models. And some artists are already using AI-generated art piece by piece to compose new artistic pictures, right? So they're using this their human talent, mixing it with the generative capacity of the AI. So those types of revolution in the news in many fields are going to be happening soon. I don't know when it's going to happen with science. It's probably going to happen a bit later, but at the end of the day, it's impossible to make those predictions. It's very, very hard to anticipate how fast or how slowly the world is going to change. Because another thing that could happen is that, there is actually an asymptotic return on just throwing more compute and more data at these models. At some point, you kind of max out. You're just unable to converge furthermore on a finer and finer understanding of the world. So we will see. We will see.
Very cool. And the goal of the general index hackathon that is coming out of DeSci Labs is just to get stuff started with this seemingly quote unquote simple index that has been put together with the n-grams and everything. Just see what comes out of it.
Yeah, and I think exactly, and understanding that in the context of metadata of generating better machine readable labels for outputs of the scientific process, classifying works of science in ways that is easier to query without the interventions of human. So I think those are. I'm not saying these are kind of low-hanging fruit in the sense that they're simple, but they're definitely something that a community can work on, right? We do not need $100 million of compute in order to make advances on that, right? So this is something that has incredibly high value in terms of enriching the scientific record. And it's also something that we can genuinely make original progress on this topic as a community here and be breaking new ground into that field, which is exciting.
It is. Anyone listening to the recording, Laura, go ahead in just a second. Anyone listening to the recording, though, y'all should join us when we do these because the chat is going crazy. There's a lot of really interesting links in there. Laura, did you have something to add?
Yeah. The co-pilot, I didn't even mention that, but okay, this is another incredible thing of these foundation models is that they learn to code, right? Just by reading the Common Crawl and other ultra large internet data sets, right? It's mind-blowing. You can literally say, hey, can you add me a button in JavaScript on my website? And it'll do it.
I have a question. I wonder if it's possible to fine-tune these models to the specific needs of, writing a review or just asking what should a specific field go or what is the hypothesis to connect. Because I didn't play with GPT-3, so I don't know how much space does the API provide.
I mean, so GPT-3 is not really, yet in the capacity to add a lot of value to the process of science. It's very useful, but it's the thing is, it will get there, right? And back to your question, I think it will definitely be able to show you where the science is going, right? What is the state? What of the state of the known things on the side effects of the COVID vaccine Moderna, right? Summarize the literature for me, right? Which study has this highest statistical power? Can you essentially, we will be able to query the ledger of knowledge, of human knowledge, in a way that is eminently friendly to humans. But there's a big but. It's not going to be very precise, all right? So there will be mistakes, and that's why we're going to be needing curators to cross-verify that information.
Okay, I think I was thinking in too much in a scientific fiction perspective. I was imagining this graph of papers and knowledge, and a machine able to learn how these graphs develop and able to predict the next graph should go. But maybe that's too
So,
much fun in the
Laura, I don't
future.
hear you too well, unfortunately. You're cutting off a bit, your microphone.
Oh, maybe I try to remove my. I'm not sure.
Oh, that's so much better.
It's better? Okay, perfect.
Oh, yes.
So I had this kind of a scientific fiction idea. I was imagining, like, if there is a graph of all the papers dedicated to specific field, I was wondering if it's possible to learn how this graph develops and then query where should it go, on which shape should it have, and this will reflect in a specific set of questions and hypotheses.
Yeah, so if it comes to if you have a paper and you want to contextualize, give me all the other papers that are similar to this one. This is a task that is incredibly well suited for AI in general, right? It's the idea of can you cluster that by similarity, right? And yeah, absolutely. I think all of those similarity clustering, all of those applications are those are low-hanging fruits. Those are things that will be doable with a good data set and a good community of people who essentially train on a data set like the general index. We will be able to do cluster similarization, categorization, and these kind of things.
Very cool. Eric.
A lot of interesting chatter.
I love the comment from Kalki about professors never having to teach again. But I think this ties back, Chris, to what you were saying about sort of how the AI is using, or artists are using the AI, and how you're referring to the scientist being curator. It's like this tool is going to be massive and groundbreaking, but there's still going to be that human element, that centaur aspect that's going to be there.
Yeah, exactly. So, and this is, by the way, it's important not to confuse these models with AGI, right? I'm sure all of you have heard of a general artificial intelligence and the existential risk that they pose, because this is clearly an existential risk for humans. But there's a very, very long way to go between foundation models that are used as in a centaur fashions with humans and what is conceived as this singularity moment AGI. So yeah, it's important to make this distinction. We are going to have a wealth of applications that will be sprawling out of these foundation models in the next couple of years, and I hope they are used in a way that is for good, right? And that we find good models of governance, to go back to this question, good models of access, good ways to essentially govern those models. And just to go back to the risk, there's things like deep fake, right? You can impersonate people, generate fake videos. You can essentially generate content that violates human decency on various levels in ways that are both extremely offensive or potentially very macabre or obscene. And so there's all sorts of reason why these companies that are generating these ultra large language models are doing all these kind of adversarial testing of it, right? They're like, okay, let's get a team of guys in the company and trying to get this thing to the most objectionable type of generation, right? They're essentially mapping out the edge cases that could be dangerous, right? And so we don't really know. That's the point. And so there's a lot of testing, a lot of ethical applications to the public release in general, and the public accessibility of large language models. And there's a lot of risk as well as these large language models not essentially being monetized in Web 2 silos or used in warfare by hegemons.
So I saw a question on the chat, actually, I think it was you, John, that kind of asked about the hackathon around the general index. So I don't want to stop this.
All this stuff is so it's so exciting, but it's related to the hackathon, right?
It is. So at this point, we are in an RFP phase. Honestly, our idea is basically to document a lot of what's coming out of this community call and to take time to come up with other potentially incredible use cases for this data set. It's not necessarily to develop large language models. It's not to train AI. It's just to come up with ways that this information could be used to help science in the future. That's what we're doing at this point, is RFP generation and just familiarizing ourselves with the data. Chris, do you have something to add to that?
I completely agree. So I wanted to give you the epic overview. And I hope that's a thing that generates, of course, a lot of excitement. But I also want to, mission accomplished. Now we've gone from the epic, and now we need to go to like what we can actually do, what's the value we can add within that space. And those are going to be fascinating conversations we're going to be having as a community. And we will be looking at the low-hanging fruits, right? The simple things, people that maybe, and I'm saying you don't need to be, again, like a professional data scientist to essentially partake into this. We're having prize, right? If you're a talented student, if you're someone with a bit of interest in machine learning, an interest in programming, right? You can actually make a small project about it, right? And I would like, I would more than happy, and I really want to be recognizing these kinds of bottom-up efforts as well, and essentially creating, a cycle of community contributions that ultimately, from which will emerge value and potentially breakthroughs, and that's incredibly exciting as well, because we will continue to grow this community, and we will continue to bring on talented individuals that will be able to see the things that have been done so far, and that will be able, to opine and add their value to it, and hopefully we can, spin off a beautiful open source projects about genuinely meaningful applications of the general index that are actionable in the present.
I find that every time I hear more and more about the goals of DeSci Labs, I find it more inspiring for the future of what's going to happen. And especially talking about AI gets me pretty fired up. But coming back to the tangible, near-to-hand things for the general index, one of my questions is, how good today is like just search around papers? And is there an API online or anything already that lets us query the general index just to search for papers easier? And then maybe secondary to that, I know it's a massive data set. Are there any recommendations on like how to build on this data set? Like, do you guys suggest AWS or
yeah,
something
so
else?
great question. We don't have an API yet set up for querying the general index. That's something that's in our plans. That's why we're going to just start with like an RFP phase, right? We first want to map out the ideas, the context, and the different ways that we could essentially mine this resource and create projects around it. I think that's a great first step. It's really an ideation phase, right? So it's really about understanding what can be done. And for this, there are a couple of fragments of the journal index that you can already download and essentially look at how the data is structured. There's also this other invitation that I like to bring out is that, look for all these other cool open science data sets like the Open Citation Index. There's also the Freya project with the PID graph, which are essentially the queried DOIs. So the DOIs are the persistent identifiers for each scientific articles, well, not each, but many, many of them. And so there's both the space within the general index to explore with ideas, and there's also ideas to explore outside of the space with closely related open data set of scientific value on the scientific record. And yeah, so proposals, drop them in the chat, but another great way to submit a proposal is to write something up, and I'm sure Eric will and I will be giving some structure to this so that we can essentially archive the first days of these communities, because that will also be part of our story together, right? We don't know where this leads. There's incredibly ambitious projects that we have in the work. DeSci is an incredibly meaningful cause for the entire Web3 ecosystem, and we should document that. We should start small, start with these community ideas, and build up to proposals and find ways to create open source collaborations, and then who knows where this leads.
Oh, you took the words right out of my mouth there, Chris. We are going to be releasing a standardized proposal sheet for ideas around the general index hackathon. Kind of starts out with just community conversation, exactly what's happening here, and coming up with different ways that we actually could use this. As we start to distill some of those ideas out down into more actionable items, we'll have a standard way for people to actually write up those ideas, talk about a couple of the resources that may be involved in actually achieving them, some of the timelines that could be expected, and just a general plan of action. So expect to see that resource coming in the near future. And then in the last kind of few minutes of the call, I did want to give a quick shout out to Ian, who's on the call. Ian, having already gotten started around creating a peer review idea that could potentially be a very interesting first use case for the journal index. He's already spun up a GitHub that anyone can come in and collaborate on. So, Ian, if you just want to say a couple quick words around that, that might be great.
Absolutely. Thank you, Eric. Can everyone hear me?
Yeah.
Yes.
Yeah, so I just did a really quick visualization on the test set for the general index, because I think the full size, like you said, is about 40 terabytes. So this is on just a few thousand papers, just to kind of play around with the data and look at the different metadata columns that are provided to us, and just sort of hypothesize some potential use cases. So I made that GitHub repo public, and I'm kind of working on the visualizations. In my local machine, I'm trying to pull out some topic extraction using LDA and some other ML techniques. And hopefully we'll be able to push that a little bit later this week. But yeah, the repo is open to use. Please feel free to use it, fork it, adjust it in any way you want. I think it should be beneficial.
I want to give you a big shout out, man, because this is a great way to start for all of you. I mean, you can essentially use what he's done to start doing visualization, to look at the columns. I mean, it's great, man. Big shout out to this. I really think it's a really interesting start, and the idea itself. So the idea was an idea I didn't have at all. The idea is, can we use, structures within citation forms, or a structure within connections of the journal index to find peer review, right? To come up with a list of experts, right, for a particular cause. And it's a very interesting idea. I have not thought of it. Just want to point it out again. It is a massive pain point for scientific journals and editors to find competent peer reviewers. And it is the type of data that is used to monetize software like Scholastica for finding peer reviewers. This is a Elsevier software, I believe. Not sure it's Elsevier, but just to give you an idea. So big shout out, man.
I went ahead and linked the GitHub on that. So feel free to scroll up to where that is for some of the additional conversation around the idea, and some of the ideas, or some of the alternate ideas that were floated around Ian's original proposal. Also, sharing my screen right now, I'm showing a small sample data set that's posted online from the general index, which if you look into it includes not only small amounts of data, but also README text that explains exactly what's in the data. So all of the different columns and definitions for each. So make sure to go through and look at that. Sorry, John, I interrupted you. What were you about to say?
No, I've got a question about what sort of proposals you guys are looking for the hackathon. Because I'm thinking if there's a lot of data in here, I bet you there could be some pretty cool visualizations, some good art stuff that comes out of it. And as much as I have reservations to NFTs, I bet you some cool, just artists might be interested in using this data in a novel way to just visualize something and get it out there in the ecosystem.
That sounds amazing. Yeah, no, proposals don't necessarily have to be exclusively scientific. If you want to talk about incredible visualizations that could be made and how that could be brought into specific kinds of artwork, absolutely. By all means, please do. Let's go to the moon.
I think there's something called the Opti project, which is kind of was my inspiration behind the visualization for the general index, and that's attempting to visualize like the entire internet network traffic around the world and across time, and it's like a rather beautiful and also like very interesting project to look at. And I totally see the general index as potentially being sort of like something very similar to that. You'll probably generate a rather beautiful web of science, pretty much using the full data set.
Every time like the word biology is mentioned, and then maybe there's like a giraffe that gets bigger every time physics is mentioned, and you just get a visualization of how many different times scientific words are mentioned in really weird ways. That might be fun. It's a big data set to play with, is my point.
No, absolutely. So I went ahead and brought the visualization Ian's talking about a little bit further down in chat. And once again, to anyone listening to the recordings, we are using the general index overview channel in the general index category as the stage chat for this particular call. So if you want to go look at some of the resources that we've mentioned here, please feel free to go use that.
No matter how large.
All right. Well, I think we're coming close to the end of time for this call. Thank you so much, everyone, for joining. I cannot wait to go back through and listen to this recording because between the chat and the words that were actually being said, it was a lot of information to actually keep up with. But this has been incredible to listen to and a wonderful conversation. So thank you, everyone.
Thanks for organizing, Eric, and thanks for coming, everyone. It was a great pleasure.
Thank you. It's been great.
Is there a journal club after this?
There is. That's a great call.
Yes.
Thank you, John. There's a journal club hosted by Protocol Labs, the people who made Filecoin, that our very own Christopher Hill is going to be speaking at around the decentralized society. So, Chris, you want to just say a couple quick things about that before we close out?
Yeah, so it's the Network Good Protocol Lab Journal Club, and it's a very important paper, essentially, decentralized societies finding the soul of Web3. And I'm going to be presenting that paper at the Journal Club and also presenting it in the context of the tool we're working on, so the DeSci nodes. So essentially, it's a great occasion for us to be commenting and testing the UX of these types of tools for presenting scientific research before an audience. So gonna try this out. Let's see how it goes.
Feel free to join at the link that was just posted in chat. That starts in 4 minutes.
Thank you.
Thanks, guys. Any last thoughts before I stop the recording? Anyone want to get in? All right, then we'll close that.